Okay. So once I will redraw this bus in terms of admittance. Okay. So I can write this as yeah. So I can write this as this term would be like this is my bus one, and I have now this I can express this. Earlier it was in terms of impedance. Now I can write in terms of y12 would be equal to 10 minus j20. This problem is solved in Hathi Sadar. Huh? So
Yes, sir.
you go through the
Yes, sir.
solution. Like if you look at the book, you will find it very difficult. But I have given you the you once after doing recording also you see look at the solution also would be easier for you. Okay.
Got it, sir.
Y13 would be equal to 10 minus J30, and then you have Y23 would be equal to 16 minus J32. Load flow analysis is not given in any other book properly other than Hadi Sadat. Okay.
Oh,
What I felt, if you read from other books, no, they have wrote some hodgepodge, you get a lot of confusion.
got it, sir.
386 point this thing in megawatts. Okay, the same thing. This is 45.2, this is MVAR, and this was 256.6 in megawatts, and uh, this was the 110.2 in MVAR, and this is the bus 1, bus 2, this is the bus 3, and also we have this as the slack bus where the initial magnitude of the slack bus is taken. That slack bus voltage is 1.05 per unit at the rate of 0 degrees. So now this thing you understood. So now the scheduled load for this thing, scheduled load, what was the value of S2 schedule? S2 schedule is nothing but in this form. It is the basically in the form of P plus JQ. Okay. So here the value of P is this. Here the value of Q is this, but this is an actual value. So we need to convert it in base. In order to convert into base, what we do is 256 actual, this is minus 256.6 plus the value of Q. We'll write the value of Q, that is J 110.2 and 10.2 divided by 100. You understood now that part how 100? 10 power 6 6
Yes, sir.
comes. So this part was minus 2.566 minus J 1.102. Now it is in per unit. On similar grounds, you calculate S3 scheduled and you will get the value of minus 138.6 plus J 45.2 divided by 100. Again, the same thing 100. Okay, because the base is in 100 MVA. Again, this is minus going away, so it would be minus 1.386 minus J 0.452 per unit. So you got these terms. Now the thing is that bus 1 is taken as the reference bus. So we take an initial estimate. First step is to take y2 of 0. What is the initial estimate we usually take? 1 plus j0. Huh? And now
Yes,
you
sir.
need to calculate this v2 value. So v2 and v3 values need to be calculated. Because bus 1 is the slack bus. Here you have voltage and angle, but these are two load buses. Here there is no value of V. Here also this is also a load bus PQ. So we need to calculate the value of voltage here V2. Here we need to calculate V3. So how do we calculate in the same way? V21 we will write the formula P2 scheduled minus JQ2 scheduled, that formula that I had shown in the beginning. P2 conjugate the first formula, right? You remember? Okay.
Yes, sir.
And how and what the formula stated that this is equal to, if you look back at the summation of Bij. Okay, this is this
Yes,
formula,
sir.
right? Wherein I'll write the formula again on side so that you this formula I'll write in different color so that you time and again look at this formula. Vik plus 1, this formula is equal to Pi scheduled minus JQi scheduled divided by Vi conjugate K. Okay, right? plus summation of Vij Vjk into Vij. So this is the formula wherein I will substitute this. So one important thing here is that when I'm substituting here, what is Vij value? So how many V? It is the summation. So how many V? From V 1 to 2 bus there is connection. Okay, between 1 and 2 I will write Vi 2 into V1. What about this between 2 and 3? There between 2 and 3 also there is connection, right? So between 2 and 3
Yes,
also
sir.
I have connection, but between 1 and 3 there is no connection. Is there any connection? Hmm?
There is, sir.
No, I'm talking about when I'm only considering for the bus 2. When I'm already considering for the bus 2, I'll keep my reference as bus 1, and
Okay, okay.
I'll take for 1 and 2, and this line over here, this 1 and 2, this point is touching 2 and 3. Okay, with reference to bus 1. And when I'll be taking with respect to bus 3, then I will see that there is one connection bus 3, one connection would be between V V23 connection, and then this V23 connection here it would be connecting to now here when I'm taking about V3 now direct connections you see
Yeah.
V3 one connection would be
Direct connection. This is
Y
that Y13 or that one. Yeah.
Y13, and one more connection in the bus 3 would be Y13
To,
and
towards
Y23.
that two.
Uh,
Yeah, okay. That is also
there,
a direct connection.
there between. So in case of V, in case of this V2, I'll write V21 is equal to P2 scheduled minus JQ2 scheduled V2 plus Y12, that is the impedance there, into V1 plus Y23 into V3 not divided by the whole. What is the whole thing? Divided by V12 plus V23, right? This is the summation, because on down
I
is the
want
summation
two plus five two. Yeah,
Y12
yeah.
plus Y23, because I'm summing. These are the values Yij. Okay, this is the summation value. Can you tell me for now this Y31? Can you tell me what would be the V31 value? V31 value would be.
Uh,
Can you tell me
will be
V3?
P3,
Uh,
P3 SCH.
P3 scheduled.
Yeah,
Okay.
P3 scheduled
My
minus JQ3 scheduled
minus JQ3 scheduled. Then
by
plus
V3 conjugate.
uh, divide by V3 conjugate. V3 conjugate and initial value you have to take here. Na? V3 conjugate 0. Here also V2 conjugate 0. I just forgot, right? Okay. Plus, tell me then the other term would be
So plus
Y1.
Y31.
No, it would be from 1 to 3. Now Y13, it would be Y13 plus Y23.
Uh, Y13 plus
Ah,
Y23. Yeah, yeah,
see,
correct.
see, why, see, this is 3 is getting connected to
So
1
correct,
and
correct. It's flowing. I got it.
Y13 and Y23. Okay,
Y13 plus. Yeah.
Y13 V1 plus Y23 V2. So this is the connection.
Yeah.
So once you got this connection, right? Now you have written both the equations. Now in that equation of
Sir,
Gauss,
one second, sir.
yeah, tell
Sir,
me. Uh,
could you please write for V11 as well?
V
V1 first iteration.
no, V1 is the reference bus. V1 is not. See, this iteration will be done only at the load, right? V1 is the slack bus. V1 is the slack bus. There would
Okay,
be
so we
no,
don't consider slack at
yeah,
all.
slack bus only voltage and this angle is there, right? Slack
Okay, I
bus,
thought, I thought.
slack bus only voltage, only this thing P and Q will come at the load bus, right?
Yes, sir. Yes, sir.
How at the slack bus there would be P and Q?
Correct,
Slack
correct.
bus, okay, okay, yeah, that definition is very important. Okay, so this term
Got it,
will
sir.
not come. So now one more thing is that Now you know the formula of that iteration. In that iteration, you can put what was the formula. Can you go back to that formula? Hmm,
Sir, one second, sir. I'm just noting it
got
down.
no. Wait, I'll write it down here. Yeah. So that Gauss Seidel formula. What was that? B calculated minus something. I'm really exhausted. This is my third back to back, but I want to
Oh,
finish this actually. Yeah. So that you have taken it down.
sir, one second. Sir. So
We
that was a procedure formula.
I just lost it. Sometimes it goes away from your memory. I'll just open this book. You know where it went. Yeah.
Sir, EI equal to is under B.
Yes, very well.
Sir, EI, sir, EI k plus 1 equals to root under VI square
No, not that.
minus.
Not that one. Not that one. Not that one. Direct formula, yeah. Direct formula. You have to put in the direct formula. Direct formula for this xk plus 1 was there now. Vk plus 1 is equal to vk plus alpha. That
That
form.
will,
Here it is.
sir,
Yeah, here it
x
is.
k
Now
plus
you
1 equals
no
to
see.
xk plus alpha.
No. Here one more formula we had written. Y vi k plus 1 is equal to v I k plus alpha vi calculated k minus vi k, right? This is the
Yeah, yeah.
this is the formula, no, right? This is the formula to do it.
Yes, sir.
So in the
That's the
first
same
formula,
formula.
see in the first formula, what you are supposed to do is that, see in the first formula v2 value you have to put for v2 one first iteration. What you do is that you substitute the values, whatever values you have got for v2 one. So while you are substituting the values for v2 one, you have the values you have here. This is the value of p, right? For here
Yes, sir.
v21, this is the value of p. P value is minus 2.566. Then you have this value of q value is 1.102. v2 also you have, v2 is the initial estimate that you are going to take 1 minus j0. 1 minus j0 is the initial estimate you are going to take. Then v12, you saw that the value of v12 is 10 minus, v12 is 10 minus j20. Here you can see v12 is 10 minus j20. Then the value of v12, after that vi is already given here. It is
Okay.
1.05 plus j0. Okay, vi is given, so vi value can be put. Then y23 is between this y2 and 3. This is 60, this is 16 minus, I'll write y23, I'll write here 16 minus j32. This is the value. So you can put the 16 minus j32. Then initial estimate will remain as it is. Initial estimate is 1 plus j0 here. Okay, 1 plus j0 here. This is the initial estimate. Okay, then y12 and y23 are there. Once you are putting in this value, you get a value of v calculated. You are getting this value, v calculated value. You are getting this v calculated value. And once you are substituting in these equations the values, okay, shall I I'll rub this point from here to here. Okay, shall I rub this point and then I'll put the
Sir,
values.
sir, no need to. Yeah, I can rub it. Then, like, this go to the next page.
Yeah, next page. Yeah, we have that option also. I just forgot. We no need to rub. Yeah. So in the next page, we can directly write these values. Okay, that would be minus 2.566 plus
Um,
j.
sir, एक second. Can you just go back?
Yeah,
One second, I want to verify.
yeah. This value, we take it down. This is for y21.
Yeah,
Up.
that's the one I wanted to type. That that I wrote, and V3 equation also I wrote. Yeah,
And
yeah, I
then
think everything I wrote.
this is the equation we have to
Yes, sir, that also I wrote. Yeah, yeah. Yes, sir.
write. Okay,
You can go.
I'll save this
That's
as well here. I'll save this PDF.
Yes, sir. I've written those, sir.
Okay, so directly you will put in those equations minus 2.566, 1 plus 102, and you put the other value 1 minus j0 plus, for that value 10 minus J20. I'll show you for other one you practice V31, huh? 1 point,
Okay, sir.
because it will take hell lot of time. I'll directly write the same process we are following there also, right? Plus
Yes, sir.
16 minus J32, 1 plus J0 divided by the whole this whole divided by 26 minus J52. Once you calculate this value in the calculator you put, you get the value minus 9825 minus J 0.0310. So once you have calculated this for V2, V21, now on a similar ground, V22, if you have to calculate the V22 value, now in the V22 value, instead of this 1 minus J0, you have to put this value. Instead of this value, you have to put this value. The rest all will be same. The rest all is same there, okay? And one more thing,
Okay.
yeah, instead of this value, you have to put the value. But one more thing is that before calculating V22, you need to calculate V31. You need to calculate V31
Correct, correct, of course.
because you have to put here also now V3. Because this term is the V3 term there. So you have to calculate
Sir,
V3.
right one that we calculate right now is V21, right?
V21, yeah, V2 before calculating V2, then you have to calculate V31. V3 when you are calculating the V31 value, again you have that scheduled power P3. Okay, then here it would be 1386 plus J 0.452. V3 formula I have written there. You have written there the same formula minus
Yes,
1
sir, yes, sir.
J0, so on and so. This is 10 minus J30, 1.05 plus J0, then plus 16 minus J32. And when you are calculating for the V31, here you have to put the value. Initial estimate will now become here. Here the initial estimate, instead of 1 plus J0, it will become this term 0.9825 minus J 0.0310. So this you have to be careful. This estimate has to be
Okay.
changing. This value you have to put here, and rest down value would be same 26 minus J52, and you will get the value of B31 as 1.01011 minus J 0.0353. Now, if you are going for the second iteration V22, okay, in the second iteration for the V22, you will have the same value on top, but on down 1 minus J, instead of 1 minus J0, what would be the term that you will be using? You'll be using this term. Okay, only this term will get in the second iteration. Down, I'll write this whole value as this uh, whole value up till here. Okay, yeah. Only thing that is going to change, I'll write in a different color. Only thing in V22 what is going to change, I'll write by black. Here also black. So this value V22, this value will be, instead of 1 minus J0, it would be 0.9825 plus J 0.310. And again for V22, instead of 1 plus J0 here, this term is going to change to the other term that is here. What was that term? V31 term, Diwali term. This term
Yes,
is
sir.
going to change to 1.0011 minus J
So basically,
0.0353.
basically that 1 minus J0 term becomes 0.9825 plus J
No,
point three one
no,
zero.
no, 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 no. When you are, yeah, this becomes for this term, it will become for this down term. If you look at the
Yes, sir.
formula, if you go back to the formula, look here. This is P. It's for V2. If you look at the formula here, this is P2 minus this thing. This term is V2K, but here this is the initial value of the V30, right? So this we have taken
Yeah.
1.30, but when we are calculating for V31, a different value comes, and then
Correct.
V32, V22, you have to put this value here, the changed value. Okay, so that is the reason I am putting this value here instead of that. Okay, so there would be
Okay,
two
got it.
changes. One is here and one is here. One is here. I'll write it down here. You just write down. 1.0011 minus J 0.0353. So on similar ground, so on and so forth. Once so V22 you will get a value. When you are substituting this, you will get a value of 0.9816 minus J 0.0520. So you got the, and similarly V32, if you are going to do V32, the initial value now will come for, the initial value here will come for, that is the value of -1, and all that thing will remain same, but the value of V31 what you got, value of
Yes, sir.
V31 what you got here is, this value will remain same. This V31 value is there na, when you are
Yes, sir.
calculating for V32. So here, instead of -1 J0, instead of -1 J0 on down for V32, rest all will remain same, 1.0011 minus J 0.0353. This term will change for V32, as well as there, here what were you seeing the value? The value you here, what you were seeing here, 1.0011 minus J032. But the new value here has come. So here the new value would be point, what is that? 0.9816 minus J 0.052. So now if you similarly try to iterate it, okay, so you will find that here, after you try to iterate, okay, this same formula you try to put, okay.
Right,
So
sir.
you, if you will not practice now, you will not get it. Even if I
Right.
talk 10 15 times, I will tell you, you will not get. You try to practice it at home, okay,
Yes, sir.
tomorrow
Yes, sir.
or today onwards. Similarly, like this only, one value you are calculating, putting in the other value, okay. So you,
Right, sir.
sim, similarly you get this V2 for fourth iteration you get, because you are putting those values, okay. And
Yeah.
finally, like if you are doing the seventh iteration V37, so the seventh iteration and the sixth iteration, the value comes around, this is the fourth, fifth and sixth you are doing. So it is there
Oh,
in the
so we have to
hard.
do 7 iterations.
No, 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 you don't do seven iterations. This is Hati Sadat book, right? You just
Okay,
go
okay.
through this. In examination, you need not to do seven iterations. You one or two iterations, it is done. One and two iterations, it is done. Okay. And in the
Right,
examination, it's not about, it's the method. Okay. You,
right,
if you will prepare for a test match, you will do in a T, well in T20 also. If you are, you
right,
prepare, your preparation should be good. Okay. You
right.
normally they will not ask like this. I know that, but I'm preparing. You know, you are like, should be prepared well. Okay.
Got it, got it.
So don't worry that you have to do seven iterations.
Yes,
Okay.
sir.
Directly you do one or two, and directly you need not to do seven iterations. You do up to three iterations, and you just see whether you are getting
Got
or
it,
not.
sir.
Okay. The rest values
Yes,
you
sir.
directly see. Okay. 0.9800 minus J 0.60600. So these values are coming close. Equation now sixth and seventh are coming very close. So we can comfortably say that our V2 value is equal to 0.9800, okay, minus J 0.0600. So we have, earlier we had only P plus JQ at the load at the PQ buses, but similarly after doing seven iterations on V3 also, we, so seven iterations, sixth and seventh iteration, V3 6 would be equal to 1.00 minus J 0.0500, and V3 7 value would be equal to 1.00 minus J 0.50. So it's becoming very close. So I'll write this 1.000 minus J 0.0500. So I have this, this is in the rectangular form, this is A minus JB. I can write in the polar form where R value would be equal to A square plus B square, or you can directly do in the calculator, right? Rectangular to polar. Okay. So in the polar form, if I, you know na, rectangular to polar, hello?
Yes, sir. Yes, sir. My
So
calculator.
yeah, 0.98183 at an angle of minus 3.5035 degrees. And similarly, you get this value of 1.00125 at an angle of minus 2.864 degrees. You are not having the voltage, you are not having voltage and angle. add PQ buses. But after doing this iterations, putting in the formula, you got like these voltage and currents. Now, if you can also, with the knowledge of this, whatever you have obtained, you can calculate the value of PA minus JQI, right? You have that formula for the PA minus JQI. What is that formula? You had this formula, right? VI
Yes, sir.
conjugate VI VI2 plus VI3. There in that formula, now you substitute
Yes, sir. Yes,
VI2
sir.
V2 plus VI3 V3. Okay, so the actual formula for this, what was that real part? The actual formula here is the, in that formula we have VI conjugate K into VI of K summation of J is equal to 0 to N Vij minus summation of J is equal to 1 to N Vij Yij Vjk. So in the same scenario, you have those values. So Vij is V12 plus V13. Okay, and here it is V12 V2 plus V3. Now this is how you can calculate with the knowledge of the slack bus power is obtained. See, slack bus is the first bus. So first bus is associated with the second and the third one. See here. If I go back, see here, this bus is the slack bus. So it is associated with bus number 2 like this. That's why I'm writing V1 Y12 and bus number 3 like this Y13, right? You got it?
Yes,
Hello?
sir.
Yeah.
Yes, sir.
So
Yes, sir.
yeah, this is the term. So I'm writing Y12 plus Y13. Okay. So here Ij is Y12 plus Y13. And how it is associated with the V2? With V2 it is associated, see, V1 and V2 it is associated with this line Y12. So this is Y12 V2. And how it is associated with V3? V3 it is associated, suppose this is V3, so with V3 it is associated like this Y13 V3. And it is whole divided by, sorry, no, it is not divided by, this is the whole thing. So you put the value, this is your initial estimate. Okay.
Yes,
So,
sir.
so initial estimate we calculated 1.05. Okay. Into
Yes, sir.
1.05 into this value, 20 minus J50. This value also minus 10 minus J20. Then you calculated V2 value from the top. V2 value is
Yes, sir.
0.98. Okay. So you can write this value 0.98 minus J is 0.6. And this would be minus of 10 minus J30 and 1 minus J 0.05. So this value will come around 4.095 minus J, sorry, I'll write it here. Yeah, minus J 1.890. So I'll save this as well by the, okay,
Yes, sir. Yes, sir.
PDF. So this is the whole value that I'm getting. If I multiply
Getting it.
this, if I multiply this, I'll get this equation Pi minus JQI. If I multiply this, I will get in terms of 4.095 minus J 1.890, right? So my real
Yes.
power is this, and my reactive power Q is this. Now, uh, at the slack bus, I was only having at the slack bus what I have, voltage and angle. I don't have P and
Uh,
Q. So with this, with the help of this, hello, can you listen to me?
Yes, sir. Yes, sir.
Uh, with the help of this, at the slack bus, I have calculated real and reactive power. I have calculated P and Q at the slack bus, right? So
Yes,
the
sir.
value at the slack bus also. So yeah, 10 minutes are more, no issue. Okay. So can I take to the next? Hmm?
Page. Yes,
Next,
sir.
yeah, next page I'll take. Yeah. So at the slack bus, my values for Pi Pi is equal to how much? Uh, 4.095 per unit. Now I know per unit is basically actual by base. Okay, base. If I need to get the actual value be per
Yeah.
unit into base. So what is my base? Base is my 100 MVA, 100 into 10 power 6. So I will do 100 into per unit. So 100 into per unit will become 4.095 into 100 into 10 power 6. So this will become 409.5 megawatts, right?
Okay.
And my Q1 value was equal to Q1 value was equal to 1.890 per unit. Now in MVAR, how much it would be? Can you tell me? What is your,
Uh,
yeah, actual value divided by base value is your per unit. Base value is your per unit.
okay,
Now
okay, okay. Yeah.
in this scenario, your base
100.
value you have taken 100 into 10 power 6.
Yes, sir.
Okay, now you can tell me if this is 1.890 per unit in MVA or how much it would be.
It will be 1.890 into 100 into 10 is power 6.
So it would be 189.
189.
Yeah, it would be 189 MVAR because this is one
Yes, sir.
because 1.1.89 into 100 will give you 189 and this 10 power 6 term will give you MVAR. So it would be 189 MVAR. So now you got the value,
Right, sir.
every value is there. Now the PI value is there, that is 4.409.5 megawatts, and you have QI value also equal to 1.890, sorry, 189 MVAR. Now you can get the losses, line losses. Okay. Now let me draw this diagram again. Hmm. Where it would be where this thing are. Now one thing I got to know is in the slack bus my there is some power that is getting entering. That is in
Okay.
terms of this is 409.5 megawatts is entering, right? And here also in the reactive volt ampere 189 is going. Then I have to see the value of this. Now I have to calculate for, now I have this formula right here. I'll redraw this bus for a time being so that you understand well. Hmm. So I'll understand the whole power flow scenario. Okay, so this was the
Okay, sir.
bus over there. So if I want to calculate, this is my line 1, this is my line 2, and this is my line sorry, this is the third one, and here also this is the third one. Okay, here to I know there was 256.6 megawatts, and here it was 110.2 MVAR. Rest values, I know here my Y12 value was equal to 10 minus J20, and here Y13 was equal to 10 minus J30. Here Y23 was equal to 16 minus J32. Can I calculate for the lines? Can I calculate
Yes,
I12?
sir.
In the beginning I have told you I12 would be equal to V1 Y12 V1 minus V2. Right? I can substitute these values. Y12 would be equal to, what is Y12? Y12 is 10 minus J20. And what is V1 minus V2? V1 value I was given at the bus, that was 1.05 plus J0. V2 we calculated, right? We calculated 1.05 plus J0 in the next slide. If you see, we calculate this value as 0.98 minus J 0.06. So we have the value of I12, right? We have the value of I12 to be equal to, if we put in the calculator, 1.9 minus J is 0.8. On similar grounds, I can write my I21 is equal to minus I12 is equal to 1 point, it was coming, it is minus 1.9 plus J is 0.8. Now can I calculate the value of I13? I13 would be equal to how much? Y13 into V1 minus V3, right? Huh? Ronil.
Yes, sir.
So
Yes,
this
sir.
is
Yes, sir.
Y13 is I13 into V1 minus V3. Substitute these values, I get the equation 2 minus J 1.0. On similar grounds, I can say that my I13 is equal to minus I31. Okay. Now I can write for
Yes,
I2
sir.
I23, I can write the value for I23. I23 value I can write Y23. I23 value
Yes, sir.
how Y23 into V3 minus V2. Sorry, Y23. This first term is there now, so it would be V2 minus V3. So
V3.
when I'm substituting this, I'll get minus 64 plus J.48. If you are getting any doubt, you can WhatsApp me also or email me also. No need.
Yes, sir.
After
Yes, sir.
after studying. So one I32 would be equal to minus I23, right? And this term would be equal to, now I have to get the values of the power. Now I have the value of V1, I have the value of V2, but I want to get the value of power. So since I have these values here, I can get the value of power S12. I'm saving this recording also, don't worry. And I'll save the slide also, the previous slide also I'll save, so that you don't worry.
Yes, sir.
In the PDF format I've saved it. I'll send it to you. So here, and it is
Yes,
there in
sir.
the Hadi Sadat book, page 215.
Yes, sir. Yes, sir.
Hadi
I see this,
Sadat,
sir.
Hadi Sadat. You just keep that book in front of you.
Yes, sir. I have in PDF, sir.
In PDF, I have sent it to you. Now,
Yes,
S1
yes, sir.
of
I
2
downloaded, sir.
is equal to V1 into I1 of 2 conjugate, right? So this
Yes, sir.
V1 value you have 1.05 plus J 0.0, 1.9 plus J 0.8. So you get this value as 1.995 plus J 0.84 per unit. So if you multiply this, actual value would be equal to 1995.5 megawatts, and because you have to multiply it with 100, 84 MVAR. On similar grounds, you S21 you can write V2 into I21 conjugate, which I'll directly write the value. This will come as minus 191.0 megawatt minus J67.0 MVAR. And similarly, your S13, because you're having only three connections, S13 would be V1 into I13, and on a similar grounds, it would be 210 megawatt plus J 105.0 MVAR. Now see at the sign. If it is sign, then it is moving away from the bus. If it is positive, then it is going into the bus. Now can I draw the
Yes, sir.
diagram for, can I draw the diagram for this? Yes, I can draw the diagram. So if I draw the
Yes, sir.
diagram, the final step would be to, like, this is the generator, right? So what is the load entering? Entering, because it was positive first value, that was 409.5, and 189 was entering. That is, this is the real power, this is the P part, and this is the Q part. Okay. And then finally you see what is happening. This part is leaving the bus. So this, it is entering, no, so this part is leaving. Which part? Minus wala part. So I'll write this 191 is leaving it, 199.5 is leaving, and here also this is the real part P, and the reactive part would be written down here as 84. Okay. And we
Yes, sir.
have the impedance value for this line as 8.5, and here we have this as 17. So how do we get this impedance of the line? That is SL12 would be equal to S12 plus S21. So S12 value and S21 value we calculated, that was 199.5 plus J84, and S21 value was minus 191 minus J67. So from here we can just get this value. Okay, this addition and subtraction value. So this